For my very first YouTube KSP series, I thought I would get into the nuts and bolts of Space Shuttle design. And that's true Space Shuttle, asymmetric fuel tank, solid rocket boosters that jettison off the sides, punt the tank off at orbit, let it smash back into the planet, and then an unpowered glided return. Now, in order to get into that, which I will in much greater detail, you really have to start off with your basic aircraft theory in Kerbal Space Program. There seems to be a little bit of fuzziness still out there when it comes to designing a proper plane, and I'm going to try to eliminate a lot of that. A side note, I do use Ferrum Aerospace mod because I just do not like vanilla KSP aerodynamics. Your glide ratios just always seem incredibly terrible, no matter how you design your plane. There are some Space Shuttle mods, some actually quite brilliant Space Shuttle mods that work beautifully in vanilla, but this is, I've got a massive mod list, takes me a while to sort through all my parts, so just kind of bear with me on that one. But I use Deadly Reentry. The latest edition of Ferrum Aerospace has reinstituted high dynamic pressure, so you will shear the wings right off your airplane if you come in too steep, too hard, making abrupt maneuvers at extremely high speeds, what have you, just like real life. But I'm going to try to keep the modded parts list to a minimum on the Space Shuttle design. There are some things that are absolutely critical, like the clock-keyed Martian Space Shuttle engines. I used to manually mod my engines using a plugin written by a forum user called Endless Waves, but the implementation and just the absolutely gorgeous models in the clock-keyed Martian pack have just completely erased all that hard work, and they're just an absolute joy to use. And when I get to them, you'll agree they are just jaw-droppingly beautiful. Okay, gonna hop in here with a basic monoplane I've set up. I am going to dissect it a bit to kind of show my reasons for why I've set it out. Now, before we begin, just an aesthetic note. Got my T-tail here. Some people don't know how to make a T-tail in KSP. Hop into aerodynamics here, scroll to the end of the list. It is just your basic vanilla tail fin and the AV-R8 winglet. I like to build my planes with a flying tail, which has the entire control surface deflect for pitch, roll. I think it looks cool, and I have noticed it's got better authority at high speeds than, say, the Delta Deluxe does in Ferrum. Doesn't really make a huge difference in vanilla KSP. Okay, that out of the way. Center of lift, center of mass. KSP Aircraft Design 101. This aircraft has been intentionally borked, and I only touch on this. Everybody knows you put center of lift behind center of mass. If you don't know why you do it, kind of think of a parachutist. Center of mass is always the parachutist himself. The highest source of drag is always the parachute. In an aircraft sense, your wings, because they provide lift and they are sticking out, they are the highest source of drag on your airplane. Now, if you have your center of lift in front of your center of mass, your aircraft will always try to swing the center of mass and lead with that. Your control surfaces can fight against it, but once you get past a certain point, their effectiveness will completely cancel out, and you're going to be flying like a lawn dart that's been thrown backwards. So, I only bring this up because as you can see, it's difficult to design an airplane in KSP with center of lift in front of center of mass and just not immediately see a problem there. For a Space Shuttle though, once I get all the equipment added to make it a functional, usable payload delivery system, you can, with the Delta Wings, it becomes quite easy to shift your center of mass too far to the rear, because engines in KSP are extremely heavy, as they should be. Okay. This has been your Kerbal Space Program PSA. Gonna move those back to the proper location. Okay. Nice little, friendly little airplane, can just barely kill you. Very easy to fly. I'm gonna do a quick demo flight right here. And I set up my staging so that when I stage, my reaction wheels will shut down. This is a completely aerodynamically flown aircraft. You don't use SAS torque. SAS will still work. It'll act on the control surfaces to try and stabilize the aircraft, but the reaction wheels will be disabled, like so. Oh, that's way too much power for this plane. 1/3 throttle is perfect for liftoff. Rotation speed on this is generally about 50 to 60 meters a second. It's a very gentle takeoff. Just kind of claw my way into the air. Throttle back, because I'm trying to keep this just a low speed demo flight. You know, do a quick recovery to the airfield, and maybe demonstrate some things about landing. Because the most critical part that a lot of people forget is your landing gear configuration. And I'll get into that when I chop this plane up, so it'll purposefully fly incorrectly. Okay, I come from a pretty extensive flight simulator background. The very first PC game I ever played was TFX, made by the old Digital Image Designs back in 1993. My dad bought that for me when I was like, I had to have been 6 or 7 when he got that for me. Played many hours flying the Eurofighter Typhoon, F-22 Raptor, or YF-22 at the time, and the F-117 Nighthawk. Fun game, but what I will always lament about Unity and KSP until they fix it is joystick support. I'm not a good keyboard pilot. I can generally fart along nicely enough without destroying too many planes, but there's a lot of these just goofy looking oscillations I induce in the plane. Okay, put the gear back down, keeping my speed low. Watch that VSI. Watching me flop around like this. There's a flight instructor somewhere in the world who just got a cold chill down his spine and doesn't quite know why. Throw some rudder, pitch up, kill the engine, and should just sink down. Alright. That's a gentle touchdown. Brakes. Running out of runway. Brakes, 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 brakes. Anytime, brakes. Well, everything was going so well until it exploded. But, in any case, recovery. If I'd come in slower, definitely would have been a much easier landing. Okay. The primary concern when landing any type of aircraft, well, any type of tricycle aircraft. Tail draggers are a whole other matter, but I don't build those in KSP, so it's a non-issue. When you come in for a landing, you always want your main gear to strike first. In KSP, because the sensitive nature of keyboard controls, it's very easy to get a tail strike, but once you know how to design a plane properly, it's pretty easy to avoid it. Now, back to center of mass. The reason why that plane was so easy to get off into the air was I have set my landing gear just aft of my center of mass. That makes it very easy to pivot up. If you think of your landing gear as a pivot point, your tail fins will induce a torque force as they pitch down. And that gives it a point to pivot around, increase the angle of attack of the wing towards the wind, and you're off and flying. One of the most common suggestions in aircraft tutorials for Kerbal Space Program is to make sure your plane has a nose up position at rest, kind of like that. And you do that by giving your landing gear a little bit more length. And I can do that by... This is another important thing to demonstrate. Okay. I'm going to slap that on there. Just give me a little... Well, I'll make it more extreme. Okay. Now, this may fall on its tail once I get it out there, but say the basic monoplane 1 so it doesn't override my other one. Okay. There we go. That's pretty good. Got a natural nose-up orientation at rest. Going to engage SAS, but once again, reaction wheels shut off when I stage, and they stay off. Put this at half throttle and fly it completely hands-off. Because the wings at rest have a natural angle of incidence towards the air, you can take off completely hands-off, which makes takeoff the first problem a KSP plane builder will ever encounter. It makes that easy to surmount. But what goes up must come down, and it makes landing much more difficult. Pretty much the second thing upon getting their first successful takeoff a KSP plane builder will ask. And I'm trying to be very gentle because I have torn the wings off this plane very easily. And that's quite a high speed. High speed for this aircraft anyway. Okay. Put the landing gear back down. As you're flying, one thing to keep in consideration when it comes time to land, you always want your tail, your main gear, to strike before your nose wheel. However, if you overdo the elevation on your nose wheel, you can find yourself in a situation where in order to get your tail down first, you either tail strike it or the plane starts to climb again. And that will lead you to wheelbarrowing, which I am going to try and demonstrate here. Wheelbarrowing obviously is when a tricycle landing aircraft landing gear configuration, the nose wheel hits first. And what this does is, if it doesn't collapse the nose gear, the nose will raise and there's a sudden increase in the angle of attack on the wings. And so it lifts back up again. It's not your tires or your suspension that's bouncing you back into the air, it's a sudden change in airflow over the wing. And I'm not even going to try for the runway for this, I'm just going to use the field. Why did that go to orbit? Okay, surface speed. And I'm coming in hot, but this should be okay for demonstration. Now, if you're looking from this angle, you are not going to see your nose wheel hit first. And when the plane bounces on landing, like that, it can be very difficult for you to figure out what's going wrong. Watching it from the side, there you go. And it makes landing an absolute nightmare. In extreme circumstances, you can get your front wheel planted, but your rear two landing gear, or just one of them, are riding along in the airstream behind. And it's very difficult to get that planted in time before you either run out of runway or hit an obstacle to get both of them planted. And if you drop the nose wheel and one of your landing gear, as I'm going to attempt to do here, one of your main gear, your plane will have it, and my speed's way out of bounds, but I might be able to pull this off. If you get two gear down, your nose and your main, the aircraft will tend to curve in a circle. Once again, bouncing. There we go. Tips over, rolls, does a little seesaw motion. That is basic aircraft design 101. Now, the thing about wheelbarrowing is this is a small aircraft with very little mass, so it's not usually much of an issue. However, the space shuttle I build is typically about 33,000 kilograms, I believe, is the unit they're using in this game. It's about 33,000 kilograms. When you land, what causes on that plane, if you wheelbarrow, it causes the wings to deflect, and that puts camber on your wheels and creates a turning force, and the plane is darn near impossible to get back on the ground when you're landing. This one, being small and stiff, it's not much of an issue, but it is something to keep in mind when you start going to a bigger aircraft, which I will get into in a later video.